In this lecture, we are going to solve an important problem of pair of straight line from your popular book of Analytical Geometry of 2 and 3 dimension. And the problem is the vertices of a triangle lies on a straight lines y this is equal to x tan theta 1, y this is equal to x tan theta 2, and the third one is theta 3. The circumcenter being at the origin prove that the locus of the orthocenter is the straight line. Straight line is given by such. To solve this problem, we use an important property of geometry or important result of triangle, and the result is orthocenter, circumcenter and centroid or center of gravity of a triangle are collinear. Okay, we use this result or property of triangle. Now we draw first the coordinate axis. This is x axis and this is y axis, right? This is x and this is y. Let the first line is this is y equal to x tan theta 1, and the second line is this is y equal to x tan theta 2, and the third line is this is x equal to this is y equal to x tan theta 3, and let the triangle be ABC. Okay, the angle of this type. This is the point A. Point A lies on the first line, the point B lies on the second line, and the point C lies on the third line. Let the coordinate of the point A, this is x1 y1, let it be x2 y2 and it be x3 y3. Okay, and since A lies on the first line, then we can put the coordinate of A on this first line, and this is given by y1, this is equal to x1 tan theta 1. So we get x1 by cos theta 1, this is equal to y1 by sin theta 1. And similarly we get the similar result for B and for C. We write directly here, this is x2 by cos theta 2, this is equal to y2 by sin theta 2, and x3 by cos theta 3, this is y3 by sin theta 3. Now here it is given that the circumcenter being at the origin. So origin, this is 0 0 with the circumcenter, and since this is the circumcenter, so we must have OA, this is equal to OB, this is equal to OC, because from circumcenter 3 vertices are at equal distance. Let the equal distance be R. Okay, now if we find the distance OA or OB or OC, we get that this is equal to root over x1 square plus y1 square. Okay, and this is equal to R. We let here, and from this relation it is clear that this is root under x1 square plus y1 square by 1, because cos square theta 1 plus sin square theta 1, and we put this is equal to R. Similarly this is also R and this is also R. So we write the coordinate of x1, this is equal to R cos theta 1, and y1, this is equal to R sin theta 1, and similarly we write for this coordinate and for this coordinate also. So we get the value of x1, x2, x3, y1, y2, y3 in terms of R and theta 1, theta 2, theta 3. Okay, now let H alpha, beta be the orthocenter. Okay, and let G, this is x dash y dash, be the centroid of triangle ABC. Now we know that the formula of centroid is given by x dash, this is equal to x1 plus x2 plus x3 by 3, and putting the value of x1, x2, x3 from here, this is x1, this is x2 and this is x3, we get r into cos theta1 plus cos theta2 plus cos theta3 by 3, and similarly we write directly y dash, this is equal to r into sin theta1 plus sin theta2 plus sin theta3 by 3. Okay, now it is given that O, this is the circumcenter. Here O is 0, 0, this is the circumcenter. Now we use the result. We state the result earlier. Since O, H and G are collinear, so slope of OH, this is equal to slope of OG. Okay, and the slope of OH is given by beta y alpha, and slope of OG, this is equal to y dash by x dash. Okay, and now putting the value of x dash and y dash here and here, we get the result. In the numerator there only remains sin theta1 plus sin theta2 plus sin theta3 by cos theta1 cos theta2 cos theta3. Okay, and we have to find the locus of the orthocenter. Okay, so we put in place of alpha we put x, and in place of beta we put y, and getting the locus of the orthocenter as this is y and this is x, so we get x into sin theta1 plus sin theta2 plus sin theta3, this is equal to y into cos theta1 plus cos theta2 plus cos theta3. Okay, and this is obviously the locus of the orthocenter alpha comma beta, and this is our required result. Okay, very easy problem, but very interesting, and use the important property of triangle. Right, thank you for watching.